Our final video for this lesson is on word problems. Word problems, I know, are not your favorite, more than likely, but they are the most essential part of math. When you get into the real world and you do math, it will be in the form of a word problem. You will never encounter a situation where they say, here's the slope, here's the y-intercept, write an equation. You may encounter a situation where you are spending money at a certain rate per day, and you want to know how long your money will last. That's part of budgeting. So let's take a look at our first word problem. One method to help you with figuring out all of the information given in a word problem is to mark the text. Hopefully you are familiar with marking the text from some of your other classes. It's slightly different when you're marking a math word problem, so we'll go through that process a couple of times. First, number each sentence. So I'm going to start by numbering each sentence so that when I talk to you about in this sentence, I see this information, we're all talking about the same sentence. So of course, first sentence is Marty is spending money, second sentence, and third sentence. Next, we are going to circle anything that we think is a key term or that is providing us with some important information. Mostly you're going to be circling numbers. $3 per day, 14 days, and $68 left. The other piece of information that we want to make sure we focus on is what are called verbal models or mathematical models. What that means is words that tell you how to set it up. So words like is means equals. In this case, however, when we're saying Marty is spending money, it's not telling you Marty equals spending money. So we're actually not going to underline that word, but that is one that you want to watch out for in a word problem. In this case, spending tells us that the rate of change is negative. So that's a word that gives us a clue for information for setting up our problems. That's the only one I can think of other than in the question, which we are going to box. You can box the entire question, but I am going to box a little bit shorter part. How much money will he have after 20 days? I'm going to box apart money after 20 days. Because that's what we need to answer. That's what we need to figure out when we can say we are done with this word problem, is if we know how much money he has after 20 days. So that hopefully pulls all of the information out, and now we need to know what to do with it. So that's the next part of my directions off to the right here. Figure out the rate of change. When we're doing linear word problems, we need to know the rate of change, the slope. That is essential information. And this part where it says interpret, that means what are the units on our rate of change. Now actually I just realized I did miss underlining a key term, underlining a verbal model, because I had already circled it as a key term. And that verbal model is per. That gives you a clue that you're looking at a rate of change. We've got 2 units. Our rate of changes have 2 units. So that is step 1. We have our slope, $3 per day. Now, one of the other words that I underlined was spending. And we talked about how spending means the money is going down or our rate of change is negative. So make sure you take all of that information into account when you're setting up your information. Next, determine a point, because we're focusing on point-slope form at this point in our learning. So we're given a rate of change and we're given a point in time. After 14 days, he has $68 left. Label your units. It's essential that you understand which piece of information is the independent variable or the x coordinate, which is always time, and which information is the dependent. How much money he has left depends on how long he has been spending money. So remember, X is independent, Y is dependent. And then we can write our asylum equation. We've got our slope, we've got our point, so we're going to substitute it in. I'm going to write that equation down for you again. Substituting our slope, which was -3. This is our x coordinate. It goes into the asylum as the opposite. And our y coordinate stays positive. And finally, we need to answer the question. The question was, how much money will he have after 20 days? Now, if you look at the point that we set up in step 2, days was our x. So I know that I put the 20 in for the x and not the y. So once we substitute our x value into the equation, we use order of operations to solve. Parentheses first. -3 times 6 is -18. Don't lose your negative sign. And 68 minus 18 is $50. So he will have $50 left after 20 days. I'll try and get this one done a little bit more quickly. There won't be as much explaining to do. So first we're going to mark the text real quickly. Circle key terms. So basically the numbers is what you want to circle. 35 families, first year, so there were some numbers that were written out for you so it weren't as obvious that they were numbers that we wanted to look at. Underline any words that are going to help you set up your equation. In this case, we don't have any additional words that are jumping out at me right now, so I'm not going to underline anything. And finally, box the question. Number of families, 5th year. All right, in this case, determining our rate of change is a little bit different because we aren't explicitly given our rate of change. We're actually given 2 points in time. In the first year, again, time is always your x coordinate. There were 35 families. And in the third year, there were 57 families. So when we're given 2 ordered pairs to find our rate of change, we do change in y over change in x. So what did I do to my 35 to make it a 57? I added 22, so that's my numerator. What did I do to my 1 to make it a 3? I added 2, so that's my denominator. 22 divided by 2 is 11, and make sure you get your units. The units in the numerator were families. The units in the denominator was year. So 11 families per year, 11 additional families per year showed up to our math family fun night. We've already got our 2 points with our units labeled. So we're going to jump to step 3. Write the equation. Choose either point you want to, substituting my slope. And I like to choose the point with smaller numbers. So I'm going to choose my first point. The 1 is going in and becoming opposite. And the 35 is going on the outside and staying normal. And finally, we need to answer our question. Predict the number of families in the 5th year. Again, our x coordinate was years, so we're going to substitute 5 for x and use order of operations to solve. So we've got 11 times 4 is 44. Plus 35 gives us 79. Label your answer. the y-coordinate represented families. So we think in year 5, there will be 79 families attending our event. And we have 2 U-Try questions.